So we're actually going to have another quiz tomorrow, right? Yeah. The quiz is going to be like a retake quiz. I want everybody to start out with an A, right? I want everybody to start out with an A. A retake quiz, but we're going to add on 2 graphing questions, graphing square root functions, and also stating the domain and range of those square root functions. So if you didn't do well on the first quiz that you just got back a couple of days ago, doesn't matter if you got a B or an F. If you get an A+ on tomorrow's retake quiz with an additional 2 graphs, then it'll replace, you'll have 2 A's instead of whatever grade you had previously. Let's take a look at the notes for today. I apologize, yesterday we might have done some kind of complicated notes. I kind of revised it. It's again section 6.3, we're going to be graphing radicals, especially square root functions. So what does a square root function look like? A radical function looks like this. Okay, now you don't really have to copy down radical function, but you should copy this down at least. Y equals a square root of x minus h plus k. This should remind you of vertex form. Okay, the vertex form was y equals a parentheses x minus h and then a square plus k. Same identical, or not identical, but very similar form when we graph parabolas compared to when we graph today's square root functions, right? Now we already did this yesterday, but I want to jot down some specific notes on how to graph, steps on how to graph. So, and this isn't the only way of doing it, but it works for me, so I hope it works for you. Step 1 is to box in the function, leave out h and k. So yeah, here's h, here's k, box in this part, ignore h and k. You're boxing in the y equals a squared of x. That's step 1. If you feel like writing this down, actually you should write this down in your notes. Step 1, box in the function y equals a squared of x. You're leaving out h and k, you're ignoring it. It's kind of like if it weren't there, right? We're pretending that the h and k is not there. We box this in, and what do we do with this? We graph the box function. So how would we graph this? You make an xy table, plug in some nice perfect square values that you could do the square root of and then multiply whatever numbers out here with your answer. That way you get nice inputs and outputs. And then once you graph the boxed function, step 3 says shift your points according to h and k. That's when you look at h and k again, and you have to think opposite on h because the h has a minus sign. That means think opposite of whatever you see, and that'll be your left or right shift. And the k value is the number that's being added or subtracted at the very end. That'll be your up or down shift. And I hope you remember back when we did parabolas, the coordinate hk, it was very important. That was our vertex, right? When we did the U-shaped curves that open up or down. Right now, the coordinate hk is equally as important. It's not a vertex, but it is the beginning point, right, of your curve, right? A square root function starts off at a certain point, it begins at a certain point, and it shoots off in one direction, right? So hk is that beginning point. And if you think about it, that beginning point are the numbers that are going to be involved when you state your domain and your range. So I hope everybody has been able to copy it down. If you're at home and you need more time, pause it, copy it down. Okay, so let's turn this, or let's go to our worksheet and let's go to where we left off. I believe we left off on that question, the last question, the bottom right corner of our front side. Now, right here we do have a values. This a value is 2, this a value is 1/2. And similar to parabolas, the a value causes a vertical stretch or a vertical compression when you're comparing it to the original parent graph. But you know what, before we get into that, we already did this one, correct? What I would like you to do is just think about those notes you just copied down. Step 1 is to box in the function y equals a square root of x, ignoring h and k. You come up with some coordinates to this function, the boxed function. And of course, since it's a square root, you want perfect square numbers. The square root of 0 works, the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. So you come up with these coordinates of the original boxed function. That's your parent graph. Those are those blue dots right there. After you graph those blue dots, you need to shift them according to h and k. Think opposite on h, take k for what it is. So h is really -2, that's why we shifted 2 to the left, and k is -3, which means 3 down. So each of these blue dots, we move 2 to the left and 3 down, 2 to the left and 3 down, 2 to the left and 3 down. Well, 2 to the left and 3 down. And the domain and range, you could use that most important point, hk. The h and the k, hk is -2, -3. That's technically your beginning point. It begins right here at -2, -3. So your domain are your x values, and of course if this is the beginning point, you're dealing with the x value of -2. So this whole thing is at the x value of -2 to the right, which means it has to start at -2 and it's greater than -2. So your domain would be greater than or equal to -2. Same thing with the y's. The y's are the values going up and down. Your beginning point has the y value of -3, and your graph is not below -3, it's above -3. So it's at -3 or above. So that's why we say y is greater than or equal to -3. Any questions? Okay, let's go down to this one, which doesn't even have h and k. So if you did follow the steps, and okay, you would box this in, ignoring h and k. Well, there is no h and k. But you still jump right to your next part, which is getting some coordinates to graph this y equals a squared of x. So let's come up with inputs that are nice that we could take square roots of. So what's a nice input to take the square root of? 0. The square root of 0 is what? 0. So when you do the square root of 0, you get 0, and 0 times the a value of 2 is still going to be 0. Now let's plug in another nice number that we could do the square root of. 1, right? The square root of 1 is what? 1 times 2, 2. Are you with me? Let's plug in another nice number that we could do the square root of. What would that be? 4. What's the square root of 4? And 2 times that a value of 2. What's 2 times 2? 4. Okay. How about plugging the next nice perfect square number? What would that be? 9. Okay. And when I do the square root of 9, what do I get? 3 times 2? 6. So, you know what? To really understand what this a value does, let me actually graph, before I graph this one, let me actually graph the parent graph, all right? The parent graph is y equals square root of x. And that's really easy to do. 0, the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So if I put the point 0, 0, 1, 1, 1, 2, 3, 4, 2, 9, 1, 2, 3, there's my parent graph, square root function. It begins at 0, 0, and it shoots off in this direction, forever going up and forever to the right from the 0, 0 beginning point. Now, if we compare this parent graph by changing the a value of 1 to a 2, what's going to happen? Well, let's graph the red dots here. 0, 0, it has the same beginning point. But then I go over 1 or 1 over 2 up, I get to that point. I go 4 over 4 up, I get to that point. I go 9 over 6 up, I get to that point. So check out this new red curve that starts off at 0, 0. What could you say happened right there? The parent graph got what? Vertically stretched. Now what do I mean by vertically stretched? Imagine this distance from here to the original point 9, 3. If I do a vertical stretch, that's like pulling it up. It gets vertically stretched, and obviously got vertically stretched all the way to this coordinate right here. Okay? So what would happen if I had a 3 right here? If I had a 3, it would get vertically stretched even further up. Make sense? Okay, so the bigger your a value, the more of a stretch. But if that a value is less than 1, what's going to happen? It's not going to be a vertical stretch. It's going to be a what? Vertical compression, right? That's where you take this parent graph and you crush it. It gets smaller. It gets smaller, right? So all of these original blue dots got stretched vertically. From here, it got stretched to there. From here, it got stretched to there. From here, it got stretched to there. But let's take a look at this other one, and let's graph this one in green, ignoring h and k. And again, you just plug in nice perfect square numbers like 0. You could do the square root of 0. That's 0. And 0 times 1/2 is still 0. I'm also going to plug in 1 because I could do the square root of 1. The square root of 1 is 1, and 1 times half is 1/2. I'm also going to plug in 4. The square root of 4 is 2, and 2 times half is what? 1. I'm also going to plug in another nice perfect square number, 9, and the square root of 9 is 3, and 3 times half, what's half of $3? $1.50, 1.5. So let's graph these new coordinates to this other graph that has a value that's less than 1. It's going to produce a square root function graph that's compressed, vertically compressed. So 0, 0 starts out at the same beginning point. 1 and 1/2. 1 over, only halfway up. 4 over, 1 up. 9 over, 1.5 up. So as you could see, this blue dot got crushed. It got compressed. It got compressed. So kind of like parabolas. You guys remember parabolas? If the a value was greater than 1, it got vertically stretched. If the a value was less than 1, a fraction less than 1, it got vertically compressed. It got wider. Bless you. So it's the same deal with any function. The a value tells you if it opens up or down. It tells you if it gets vertically stretched or compressed. Flip this paper over and let's look at the back side. So number 1, everybody should be able to do. That's a regular parent graph. So I'm not going to do that one. We already did that one on the back side. Let's jump to number 4 right here. What does the steps say for us to do? Identify H, K. Box in the rest. Ignore H and K for a while. Make an XY table for that boxed function. Okay. So what values am I going to be plugging into the square root of x right here? What am I going to put in? What works? The square root of what works? 0. And when I do the square root of 0, what do I get? I get 0. When I do the square root of 1, what do I get? When I do the square root of 4, what do I get? When I do the square root of 9, what do I get? 3. So these are my coordinates. I should graph them and then shift according to my h and my k value. So what's my h and my k? -7 and 0. So what does this mean? I'm going to be going 7 units to the left and 0 units up or down. 0, that means you don't move up or down. Okay. So you could plot the points and then shift them 7 to the left, or you could actually understand what shifting 7 to the left is. That would involve your x values, and you could actually subtract 7 from each of these x values of the coordinates to give your final resulting coordinates instead of having to draw the original and then shift them over. It's totally up to you, right? So you could just plot them 0, 0, 1, 1, 1, 2, 3, 4, 2, and 9, 3. So there's my original parent graph of a square root function. And now let's shift them, every single one of those, over 7 units. So this guy, you're going to go 1, 2, 3, 4, 5, 6, 7 right here. So I want to put the shifted one, the final one, in green. I mean in blue, sorry. And if you shift the other one from here, it'll be over here, 7 units. And the other one will be right there, 7 units. And this one is 1, 2, 3, 4, 5, 6, 7 right there. So here's your new final graph. What's the beginning point? It's your h and k, the hk. So what's the beginning point? -7, comma 0. Okay. Now that hk value, that beginning point, will help you out when it comes to domain and range. So the domain would be x is what? If you say x is all real numbers, that would mean that it goes to the left and to the right forever. Yeah, so the deal is this. Does this graph exist at -7 right here at this beginning dot? Yes. Does it exist at -8? No. It starts here. It doesn't exist over here. It doesn't exist at -9 or -10. It starts at -7 at the x value of -7, and it's also at -6, -5, -4, all the way 0, 1, 2, 3, 4, 5. It's going to continue this way forever. So in terms of x's, it starts at the beginning x value of -7, and it's greater than or equal to -7. Okay, how about the range? The range are your y values greater than or equal to that beginning y value of 0. That's right. Okay. So again, what do? We box in the function, ignoring h and k, make an xy table, come up with some coordinates, and then shift those coordinates according to h and k. Now, if you didn't want to do the shift, if you wanted to deal with this numerically, instead of actually counting, oh, this one, 1, 2, 3, 4, 7, this one, 7, this one, 7. If you don't want to do this original graph and the shift, you could from here simply subtract 7 to your x values. Because if you're shifting 7 to the left, that means that you're going to be subtracting 7 from all of these x values. So you could have said negative 7, 0 is your beginning point, which it is. Negative 6, 1 is your next coordinate. Negative 2, 2 is your next one. And 9 take away, oh no, I messed up. Negative 3, 2 is the next one. And 9 take away 7, that's 2, 3. So those would be your ending results. So it's up to you if you want to graph the original ones and then shift, or if you want to take away this value from your x's, or if you had a k value, you'd also have to take it away. I'd rather just shift. It's a little easier for me. I already happen to have done number 2 here. If you want to check your answer, watch this video, hit pause so you could check your answer right there. Same thing with number 3. If you want to check your answer, hit pause on the video so you could see that later. Right now I'm jumping to number 5. Okay, so what am I going to do first to start graphing this thing? Box it in, right? Y equals square root of x. There is no a value. The a value is 1. So this works out pretty easily. It's going to be the same inputs and outputs as our parent graph on a square root function. So plug in 0. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. What's your h and k value? That is correct. On h, you think opposite of what you see here. So that's a negative 4. K, you take it for what it is. The number that's being added or subtracted at the very end on the outside of the square root or the parentheses. That's your k value. So what does that mean? That you're going to end up shifting your coordinates 4 units to the left and 5 units down. Okay? Now, this is what I'm talking about, that you could either do this visually by graphing them and then shifting 4 to the left and 5 down, or numerically, you could technically subtract 4 from all of these x values and subtract 5 from all of these y values, getting your new coordinates. But you don't have to do that. As a matter of fact, I don't really do that. I usually just graph the original coordinates, 0, 0, 1, 1, 1, 2, 3, 4, 2, and 9, 1, 2, 3. Okay. So again, let's use our hk value to identify our beginning point of our new graph. What's that hk value? It's negative 4, negative 5. So from the origin, you're going to go negative 1, 2, 3, 4, negative 1, 2, 3, 4, 5, and put a dot right there. Sorry about the shift. But anyway, then you move this one 4 over and 5 down. You end up with right there, and so on, and so on. Let me see. 1, 2, 3, 4, 1, 2, 3, right there. So here's our final graph with those blue dots. The beginning point is negative 4, negative 5, and it does go up and to the right forever. So we could actually state the domain, which is x is what? Greater than or equal to that beginning x value of negative 4. And the range is what? Y is also greater than or equal to that beginning y value of negative 5. So we're going to have 2 of these on the quiz tomorrow. You're going to have to graph. I think you get 2 points for graphing, and you get an extra point for identifying the domain and range.
Extra as an extra credit?
No, not extra credit, like as in it's worth 3 points. There's the answer to number 6. In case you wanted to double check it later, hit pause when watching this video. The range for number 5 was y is greater than or equal to negative 5, because you're at the y value of negative 5 and it's above negative 5. It's at negative 5 or above, so y is greater than or equal to negative 5. So just for the record, guys, we're going to have a quiz tomorrow. It's kind of like a retake. I would definitely study this quiz that you got back a couple days ago. All right? You're going to have the same type of questions. We're where you are simply adding both f function and g function, where you're subtracting f and g, where you're multiplying f and g, and so on and so on. We're also going to have other questions where you're plugging the number 1 into the g function, getting an answer, and then plugging it into f and getting an answer. So I would definitely study this. Are there any questions on this quiz that you were just like, I still don't know how to do it, so might as well throw it on this review video? Are we cool with this entire quiz? Number 12. Let's take a look at number 12, because what's the difference between 11 and 12? Well, 12 has a little star next to it. No. Well, 11, you're plugging in a number into your h function, and you get a number as an answer, and then you plug in that number into the f function and get a number as an answer. But right here, it doesn't have a number to plug in. So you really have f of x that you're going to plug into the h of x, simplify it, and then plug it into the g of x. So on number 12, you're plugging in the f of x, which is x squared, into the h of x function. So without showing much work, I want to take this f of x function and plug it into my h of x function. So what is h of f of x? That's really an x squared right in there in the place of x. So that's really just x squared plus 4. Are you with me? So once again, this h of f of x is simply x squared plus 4. And you still have to plug in that binomial x squared plus 4 into the g function. So what is the g function? The g function's right here. It's 5 times x. So the g function is actually 5 times x. And what is the x value that we're actually plugging in? This binomial x squared plus 4. So when you put an x squared plus 4 right in there, you'd have to distribute 5 times x squared. That'd give you a 5x squared. 5 times 4, that's 20. There's your answer to g of h of f of x. 5x squared plus 20. I saw a lot of people mess up on this one. It was pretty easy. You just graph y equals mx plus b, crosses at -2, goes up 1, 2, 3 over 1, up 1, 2, 3 over 1. You could go with that pattern backwards. Identify those coordinates, switch the x and the y's, and you'll have the inverse function right there as well. Down here, where they ask you to verify if one function is an inverse with the other, if they're inverse functions of each other, you need to do 2 problems. That's why they were worth 2 points. You have to do f of g of x, and it better equal x if they're inverse functions. If it doesn't equal x, you could just stop and say they are not inverse functions. Then you have to do the other problem backwards, g of f of x. Okay? And it should also equal x. So these are 2 problems. This is just the setup. This is not the work. But you need to set them up like this. You need to simplify, see if they both equal x. And if they do, then they are inverse functions. If they don't, they are not inverse functions. There's one other question I want to go over. It's one that's ridiculously easy that so many people missed. And that's number 4. Right? Yes, a lot of people missed number 4. Remember, on this first part, you're just either adding the functions f and g, subtracting, multiplying, dividing. The dividing part, which one goes on top? The f function. Which one goes on the bottom? The g function. This x is just notation, right? So all you have to do is write the f of x function, the 2x plus 1, up on top. And on the bottom, you're going to write the g of x function, which is x minus 3. And that's it. That's your answer. It's like a free point right there. But you have to state the value that'll mess up that fraction. Remember, you never want a 0 in the denominator because it would make it undefined. So the additional thing that you should write is that x cannot be 3. And x cannot be 3 because if x were 3, 3 take away 3 is 0, and that would be undefined. So we don't want that to happen. So this is your answer. A lot of us didn't put this. You only got half credit. Tomorrow's quiz, same deal. Write it. Find out what value would make it 0. You don't want that to happen, so put x cannot be that value that would make it 0. Okay? All right, I'm done.